Hey everyone, in this video we'll be looking at Chapter 7 of Dive into Python by Mark Pilgrim. It's called Regular Expressions. So, what are regular expressions? A regular expression is a sequence of characters which define a pattern and is used for searching, replacing, and parsing text in what is appropriately called pattern matching. Even though the regular expression syntax might seem bizarre at first, it is handy for operations that string methods cannot perform. So first, let's see why regular expressions are needed. And here's a simple example. The need to standardize street addresses. Let's say we want to replace the word road with RD in every address. Pretty simple, right? We can just use the function replace like this. S equals that, and then s dot replace road with RD. But what if we have a string like 100 North Broad Road? We will get 100 North Bird Word as a result, because road is a subset of the word broad, and that doesn't seem very right. We could fix this by using search and replace only in the last 4 characters of the address, where the word road should normally appear. And you can see that here in 1.py for Chapter 7 of the examples repository. But this is dependent on the length of the string. What if another thing we need to do is replace street with st, or boulevard with blvd? Things are getting pretty complicated now. So let's see how we can do this using regular expressions, which we sometimes use the acronym regex for. First of all, in order to use regex in Python, we need the module re, which logically stands for regular expressions. For a better understanding of what we're about to do, please read the Python docs for how the syntax works. I will, of course, have a link for that in the description. So let's see what we need for this particular task. The qualifications that we need. So the first is match road only when it is at the end of the string. In regex, the $sign means end of the string. There is a corresponding character, the caret or chevron, which means beginning of the string. So we need to write road $sign. Second qualification, match road only when it is its own whole word, not a part of some larger word. In regex, you use \b, which means a word boundary must occur right here. By the way, you can see this going on in 2.py. We must not forget that in Python, the / character in a string must itself be escaped. So the expression becomes \b road $sign. There is another way of skipping or escaping characters in the RE module, and that is by adding an R before the string itself. But be careful with this. This skips any characters that should normally be escaped. In case we can't find road at the end of the string, all we need to do is remove the $sign from our regular expression and replace it with another \b. That's all available for you to examine, like I said, in 2.py. So let's move on to the next one, 3.py. And let's try now to create a pattern for extracting valid Roman numerals. As you may know, Roman numerals are composed of 7 characters that are repeated and combined in various ways to represent numbers. I is 1, V is 5, X is 10, L is 50, C is 100, D is 500, and M is 1000. So how do we validate Roman numerals? We will take it one step at a time, starting with the thousands, which is represented by the letter M. This episode of Dive into Python chapter summary is brought to you by the letter M. I said, trying to impersonate Sesame Street. In order to have a number made only of thousands, we can have from 1 up to 3 M letters. So valid Roman numerals in the order of thousands are M, MM, and MMM. The pattern matching of any of those combinations is caret M question mark M $sign. And here's it's this one right here. And so let me explain what in particular those are for you. So the caret means beginning of the string, two M letters, each followed by a question mark, means that the preceding character is optional. So you can have these M's here, but you don't need to. Another M, which is not followed by a question mark, means that it must always appear in the string, right? Because at the very least, our 1000 string will have one M. And then, of course, the $, which means end of string. Hence, our pattern will match any of the name strings above. And before we see it in action, let's find out how we can search for a pattern inside a string. The re module has a function called search, which is exactly what we're looking for. The function returns an object containing many methods if an occurrence is found, or none, which is nothing in Python otherwise. For example, our pattern will return an object of strings, m, mm, and mmm, but it will return none for mmmm, as you can see here in the rest of 3.py in the examples folder. The letters C and D can only appear in 4 cases in Roman numerals. C is 100 and D is 500, by the way. CM, which is 900, CD, which is 400, 0 to 3 C characters, and D followed by 0 to 3 C characters. Checking for these cases, you can see it's getting a little bit complex here in 4.py. So checking for these cases can be written as CM, CD, D question mark, C question mark, and so on. So let's get into what that whole craziness means. The parentheses, which define a set of 3 mutually exclusive patterns separated by vertical bars. So within these 2 parentheses, there are 3 possible combinations here. And it can only be one of these. It cannot be part of this and part of this, because the pipe is separating it. The first 2 exclusive patterns are exactly what's written there. The last one means that both the D and 3 C's are optional. Combined with what we have written before for the thousands, we have an extra question mark for the last M to make it optional as well. We get that whole conflagration there. This is an example in 4.py. By now you're probably starting to wonder why regular expressions actually solve anything, since we use such a long expression for only a couple of cases. But the truth is that usually there are many ways to write a pattern. So let's see another way to look at patterns in the next example. So check out this in 5.py. This is a different syntax, m, n syntax. By using curly braces with m, n, the pattern will match from m to n repetitions of the preceding regex, attempting to match as many repetitions as possible. Omitting m specifies a lower bound of 0, and omitting n specifies an infinite upper bound. So for the before example where we wanted to match from 0 to 3 m's, we can now write m 0 to 3. Or even better, m without the 0 and just comma 3. Our previous example becomes a lot simpler, as you can see here, matching in the rest of the examples in 5.py. So how about for 10s and 1s? And you can move over to 6.py for this next bit. So before we had this curly brace notation, this mn syntax, it would have been, D question mark, C question mark, C question mark, C question mark, and it's just so much. But now you can bring it back quite a bit with this and just say, 0 to 3 C's, 0 to 3 X's, 0 to 3 I's, and so on. And that just makes it a lot easier. So go ahead and run this through your interpreter to see what that results in. This is all pretty nice, but as you can see, regular expressions are not the easiest thing to read or understand. It took us quite some time to understand the entire pattern that we use just from Roman numerals. So let's now go ahead and discover a way to be more verbose when writing regexes. By the way, there are a lot of online resources that you can use to kind of generate regex for you. One of my favorites is rubular.com. I'm not entirely sure if this is language agnostic. I think it may only be for Ruby, but I certainly come here whenever I need to do a given regex task. And so you can type in here, like, if you wanted to find Dan's, you could do Dan and Daniel, and then you can sort of say, you can see here, there's 2 matches, but if you only want this first one to match, you can say, okay, where's end of line? Oh, it's the $sign. Okay, now, like, we have the match that we want, and we have the exclusion that we don't want. So Rubular and ones like it will be very helpful for you when you're like not quite sure what syntaxes you need. You can go here and it'll help you construct it.